Hi, how's it going? Just a quick one today. So where we are at the moment is we can make triangles, right? And we can put textures on the triangles and we can transform them and stuff. This is cool. I mean, we're starting to get closer to being able to make a 3D game, for instance. What I want to look at today is if we are drawing larger geometry, like a quadrilateral in this example, well, then we decompose that into triangles. And if I label each of these points and we use the counterclockwise notation, then we can see that we kind of have this first set of 3 vertices defines one triangle, and this second set defines a second triangle. And we could pass this into memory as a vertex buffer and draw it with arrays, but the problem there is we would have to define these 3 points and then define these 3 points, and if there was a double up, that point would still be redefined, so we'd be using 6 points to draw one quadrilateral, and on more complicated models this gets worse. So what we want is we basically want to have a set of points, 4 points. We only define them once. That's our vertex buffer. Vertices. And then we have this index set here, which defines which points to include. And this lets us cut down our memory usage. Right, but that's enough theory. Let's actually have a look at it. So just get all of this out of the way. Okay. So here we have 3 points, and I'll just run this to confirm that yes, it is working. Cool. There we have our thing, triangle, whatever it is. Now I'm just going to copy paste this code because it's no fun watching code get typed, or at least it's not new code, right? So what this is, it still positions, color, and texture coordinates, and this is to define a rectangle. So I'm not going to worry about that stuff just yet, but now let's create a vertex buffer. Okay, vertex buffer. So the first triangle in the quadrilateral is going to use indices 0, 2, and 1 in that order. I'm just doing the same as the thing that I wrote before, and then indices 3, 2, and 0 in that order. Okay, just note it is possible to use 16-bit integers instead of 32. I just felt like going with 32 for this case. It really doesn't make a difference. So then what do we have? Well, we've got a vertex buffer and vertex buffer memory. Let's create an index buffer. Index buffer memory, awesome. And then we'll go down to the create stuff. And there it is. Okay, create index buffer. Now let's go ahead and create that function. Okay, here's our vertex buffer. Looking at this, I think we can just copy paste this code exactly and just modify a few things. So each of these are 32-bit integers, so we'll use that one based on Huh. Why don't we have that? Indices, okay. Guys, when I make a mistake, you got to tell me in the comments before I fool myself. That's a joke. Okay, cool. So we're going to reserve some data. Yeah, we are going to make a staging buffer. This looks great. Yep, so again, the purpose of the staging buffer is we get the data from the CPU onto there, which is what we do here. That's great. And then we want to, not the vertex buffer, but create the index buffer. And that is the one that's going to sit on our card with device local memory. Okay, so then we copy the staging buffer to the index buffer and then destroy the staging buffer. That's looking great. Okay, now we will also need to destroy our index buffer when we're done with the program. So we go down here, and here we're destroying the vertex buffer. It doesn't matter what order we do this. That's not great. Okay, cool. So then we just need to modify our drawing commands. So commands, create command buffers. Now let me see if I remember how this works. So what we want to do, we bind the vertex buffer, then we call bind index buffer, and that takes the command buffer we're working on, the buffer that we're binding, the offset that's 0, and the index type. Let me see if I remember this. This is index type, you went 32. So if we used a different data type, that would be fine. We just have to change this flag here. Cool. So that's looking good. Then over here we go command draw, but we use command draw indexed. Let's just redo this. Okay, so we're on command buffer. Because the number of things we have in our index buffer is a number of points that we're drawing, if that makes sense. And then index count, instance count is 1. First index is 0. Vertex offset is 1. First instance, I believe, is 0. Cross our fingers and see what happens. It's not great. Okay. Okay, I think I see. I think I know where the issue is. Down here when we created the index, here where we create the index buffer, we are going to be using that, declaring that we're using it not as a vertex buffer, but as an index buffer. Maybe it's this. This should be indices data. That's it. Got it. that's cool. So we're saving a bit of space by using indexed drawing. Cool. It's going a little fast though, so if we want, we can go down. No, don't save that. Go down to update uniform buffer, and down here it says in the rotation, this is like 90 degrees per second, so we'll dial it back to 30 degrees per second, and the other thing we'll do, I'm going crazy, no, we already destroyed that, so we are good. Run this again. Cool. And we've got it, it's working. It's nice and slow, we can see all the details. That's cool. So I'll be expanding on this next time, probably like trying to draw a cube, but trying to set the depth buffer properly. We'll get to that. All right, that'll be it for now. Have fun. See you later. Bye.